Hello, wonderful people. Here we are, section six, power transmission. Almost all electric energy sold today is in the form of alternating current because of the ease with which it can be transformed from one voltage to another. Power is transmitted great distances at high voltages and correspondingly low currents. Why? This reduces energy losses due to the heating of the wires. Power may be carried from power plants to cities at about 120,000 volts or more, sometimes double that. Step down to about 2,400 volts in the city, and finally step down again to 120 volts in your house or home. Power transmission uses transformers to increase the voltage for long distance transmission and then decrease it to get to your house. Everybody recognizes that, right? That's the one right there at your house. This is where I used to work, in the place that made electricity. We made it at around 22,000 volts, and then we'd step it up to 120,000 volts to put it into the switching yard. The switching yard would carry it dozens of miles, maybe 100 miles, to where it's needed, the city and all around the area. And then once it gets from the 100,000 volts, it usually gets shipped around, not 2,200, more like 4,600 volts around town, and then 120 into your house. Energy then is transformed from one system of conducting wires to another by electromagnetic induction, which is what we've been talking about. Why is almost all electrical energy sold today in the form of alternating current? To reduce energy losses due to the heating of the wires. So you might remember that the more current you put through something, even though this copper wire has a very, very, very low resistance, it still has some resistance. And so the way that it gets heated, we call the I squared R. It's a matter of the square of how much current is going through there times the resistance of the wire. Now, when you're just pushing around a few thousand volts through a transformer like this, it's not that big of a deal. But when you're pushing 120,000 volts, when you're pushing 120,000 volts, that's pushing hundreds of amps. If we took that down to 6,000 volts, we would have to push tens of thousands of amps. So if we're talking the difference between tens of thousands or hundreds of amps, that's 100 times difference. So remember, I said it was I squared. So the amount of heating of the wires is not 100 times worse at the lower voltage. It would be 100 squared, or 10,000 times worse. So that's why we always want to up the voltage as high as we possibly can when we're transmitting it dozens and hundreds of miles. That's the long version of the explanation. What do you need to know? Oops. I hit the wrong button and now I'm lost. Oh, why am I still hitting the wrong button? So sorry. It reduces energy losses due to heating of the wires. That's why we send it up to hundreds of thousands of volts to transmit it from the power plant, which is usually dozens or hundreds of miles away from the city where it's used. Okie doke.